CPO is a technology where we bring the optical connections all the way to the package itself, right next to the compute, either the custom compute or the switching silicon. And the fundamental challenge we're solving with CPO is density and power. Now remember, the number of connections inside the rack is like 10x the number of connections between the racks. So if we just try to use the same optical technology used across the racks in the data center, you wouldn't have enough power, you wouldn't have enough physical space, you cannot fit all these standard optical modules and cables as they are today. It just doesn't work, it's not possible. So the industry has been inventing this co-package optics concept, which brings the optical fiber right to the package, and it tightly couples the electronics that drive the signal over the fiber directly with the custom compute or switching silicon. So this is a massive change, and it's hard because you're combining some of the most advanced technologies in the chip industry, leading edge CMOS, silicon photonics, advanced packaging, optical interconnect, all manufactured in a small, tightly integrated system. So the complexity is very high, but it's the only way to continue scaling bandwidth and overcome this limitation that I talked about with copper, while reducing power at the same time. So this is where the industry is headed, and this is one of the reasons that Marvell has invested for more than a decade in silicon photonics, optical DSPs, all the analog broadband components around it, and all the advanced packaging you need to pull this off. It needs to all come together actually in CPO. So this isn't some futuristic thing, guys. Okay, it's happening now. And in fact, I brought a couple of Marvell examples with me today, so let's do a quick show and tell. Okay, so over here you have a traditional Ethernet switch. This is our 100T Teralink switch that we announced today. And you guys are the first to see it, actually, everybody here in the room. You can see the switch in the middle of the board. Copper traces inside the PCB carry the signal to the front panel, which is here, and this is where all the optical modules plug in. Now, let's move over here. This is a CPO-based switch right here. Now notice that there's still the switch silicon in the middle. That's right in the center of the die, of the package. In this case, this is our 51.2T switch, and all around the edges are 16 3.2T optical engines. So the 16 times 3.2, you get 51.2. So this is the fibers directly attached now to these engines. It's not to the front panel. So we've completely eliminated the copper traces on the PCB. Light comes directly out of the package. Okay, this is a very, very complex piece of engineering, and it was very cool to be able to show this off today. Okay, so co-package optics is here, and the industry is scaling up to meet the challenge. And as we've seen time and time again, every time we reach a physical barrier, we break through it with technology and innovation. In this case, by replacing copper with fiber, because unlike electrons traveling over copper wires, the distance that photons can carry a signal through glass is largely unrelated to the bandwidth. So as AI infrastructure demands even higher transmission speeds and needs to scale to larger and more complex systems, spanning millions of processors woven together now, not thousands or hundreds, optical connectivity will increasingly become the de facto solution. So the real question becomes, what does it take to deliver optics across the full AI infrastructure stack? What's it going to take? Well, it starts with recognizing there is no single technology for the entire data center. It's not how this works. There's no one-size-fits-all. There's no one-size-fits-all solution. There's no shortcuts. There's no easy way to the end here. There's not a single architecture, modulation scheme, frequency band, unique technology that's going to do it all. There's no free lunch. That's why we are pursuing a bunch of different unique optical paths across every distance to get here. Each one of these technologies that I have up here is optimized for a different design point. Each one enables a critical part of the infrastructure and addressing different requirements for density, bandwidth, and power and integration all across the stack. So if optical interconnect is the underlying technology for which next generation AI infrastructure is built, then Marvell is building the broadest portfolio with the deepest bench in the industry.